Oh, this trapezoidal.
Oh, this one will.
Oh, this handle.
So
We're good. We're going.
Okay.
Don't breathe on it. Don't touch it. When Chuck's in the room, make sure you speak loudly, or use the microphone.
Okay. Remember, three twists in your name.
And set this up so I'm not sure.
it works. Hold the power button down when it's on. It'll be an LED. It lights it. Okay.
Alright, is this saying now? Is it now on?
No.
Thanks.
Okay.
Hello, everybody. Thanks for coming today. We'll be talking about intercepting mobile communications, to the point of which is going to be to do testing on mobile apps and to also test your how your applications operate on mobile devices, with respect to security. So a little bit about myself, if I haven't met you yet. Spent a good part of my time at a major logistics company doing testing on applications, web applications, mobile databases, whatever application you can think of, and also the networks on which they run, their servers, and their obviously Wi-Fi on occasion. So also spend considerable time with developers, training them how to write secure code and fix issues that have been found by vulnerability scanners or pen tests or things like that. Teach a little bit as well. And I'm the Director of Education for this ISSA chapter here in Kentucky and the owner of Ellipsis Information Security. So what is it that we're going to be talking about today? Well, essentially, how safe is it to do serious, sensitive transactions on mobile devices? So mobile communications essentially has two avenues to communicate. You have the cellular and then Wi-Fi. The cellular, relatively speaking, is a little bit safer. There's not as many tools available that are point and shoot. The material, the equipment that you need to get into mobile interception is a little harder to find, a little bit more expensive, and there doesn't seem to be as many people that understand the protocols quite as well, as far as GSM, CDMA, and those types of things. Obviously, there's a whole lot of people that understand Wi-Fi really well, and there's a lot of tools that are available. They've gotten to the point to where you can almost just run the tool, and the tool pretty much takes care of itself. And we're going to look at one such tool today called Mana. With your Wi-Fi devices, they want to connect. They'll connect to anything they can and try to stay connected all the time. Once you connect to a Wi-Fi access point, most of them offer the option to remember that access point and even connect automatically should they see that access point again. And what they're using to identify that access point is the SSID, the name of the network. It's not actually the MAC address of the access point or any of the other information that's available upstream. This makes sense because with Wi-Fi, you want to be able to roam from access point to access point as long as the SSID and the encryption and the password and the username and all that are all the same. The username being the SSID and Wi-Fi access points. So the devices can roam freely from MAC address to MAC address, access point to access point, and not get stuck having to ask you for permission every time you walk down the hall if you really want to connect to the second access point when you came off of the first one. If there's a tie between two access points with the same name and configurations, the signal stream wins. So that brings us to this tool, Mana, which has the capability of being an evil access point. It's from two authors, Dominic White and Ian de Villers. They worked for SensePost, and they debuted the original version of this tool recently at DEF CON 22, I believe. It was just a few months ago. And the original video from that presentation is available on Adrian's site at irongeek.com if you want to check that out. And since then, they've improved the tool even quite a bit more. You can get it at GitHub. There are a couple of other tools with the same name, and there's even another tool on GitHub itself with the same name. So the way I found it was Googling SensePost Mana, and that got me to the right tool on GitHub. What it does is it listens for those mobile devices that are seeking out the networks that they had connected to previously. When it sees a mobile device, ask if its home network is in range, it copies the SSID that the mobile device was looking for into a response and says, yes, I'm your home network. So the mobile device, who's just looking for the SSID, is willing to connect because it believes that it's got back within range of its preferred device. And you'll have a whole list of devices inside of your mobile device. If you look in there right now, you'll see that if you go to your network settings and look at the mobile devices you've connected to, you'll have a preferred network list in order from top to bottom, or PNL. And your device will want to connect to the first one, then the second one, and the third one. If any of those come in range, it's going to have a tendency to want to connect to those if you have it configured that way. On the Androids and the iOS devices that I've looked at, they, by default, lead you to have that configuration set up that way. You can disable it, but on average, most people will have it auto-connect. So, talk a little bit about installing Mana, which actually got a lot easier about 20 days ago when Dominic posted an installation script for Kali Linux. When you go to do the installation, what the installer will do is it's going to try to install some prerequisites first. And I've only tested this specifically on Kali Linux. I did notice that there was an installer for Ubuntu, I believe, as well. I haven't checked that one out. But on Kali, it'll install a couple of libraries that are needed to get it running, and another program called host APD, which is the main program that actually creates the evil access point, the impromptu access point, if you will, that does the work of taking care of, having the mobile devices connect. And then it runs, installs some services that's going to run in the background. So we have, for example, Mac Changer, which can change the MAC address on the network card that you're using for your access point. We have DHCP servers and DNS servers and other libraries that get installed. The last thing it does is it actually installs Mana, and it does that via a makefile. In the makefile, it's going to put the binaries in the user share Mana toolkit directory. The libraries are going to go into the user live Mana toolkit. And then, particularly important if you want to change anything, is the configuration files, which are in etc Mana toolkit. So the nice thing about this is that this installation script puts everything in the standard locations. So it's relatively easy to find it if you're used to using Linux in general. It's also going to install an Apache web server, because one of the modes that it can run in, besides being just the evil access point, is it can impersonate a captive portal. If you've stayed at any of the major hotels, Marriott, Hampton, Hilton, you know that when you try to go out to the internet, you get the login screen. It may ask you for a username and password, group number and key, coupon code, whatever, right? And you have to put that in order to be able to get past the captive portal and then off onto the internet. And this software can impersonate one of those captive portals and ask the user to log in. Take a look at that a little bit more later. So, one of the things you may want to do after you install it is you might want to change the configuration a little bit. I find the defaults work very well, and I have those listed here on this slide. The upstream connection in the PHY, you can think of this as upstream as being your legitimate internet connection coming off your computer, and then the PHY is the access point. So in this case, I have an Alpha Networks card. This is the 036NH model, and this card works the best for me. I tested the 051 and also the 036 Atheros version, and I didn't have quite as much luck with those. So I ended up sticking with the 036NH, and if you want to try this, it worked for me. That might not be a bad choice, and they're not very expensive either. You can change out the antennas on them to get a bigger gain. Remember, if there's a tie between two access points, signal strength wins. So having the ability to change the antenna out on your card may be an advantage to you. You can change the host name of the access point and the other configurations as well. One of the things that I did like to change was the name of the SSID of the access point. by default, it's going to be internet. But you can change that to free Wi-Fi or ATT Wi-Fi or airport Wi-Fi. Well, maybe not do that one. That's probably going to get you in trouble. But you can change the name to the other ones, and we can take a look at that. So let's make this just a little bit bigger. Is that okay in the back as far as the text size? Or one more? So if we do. So while we're in downloads here, when you download it and you unzip it and look in the mana directory that you just downloaded, this is the calling install, that shell that we talked about a minute ago. You would run that. It's going to go through that progression of installing the prerequisites, and then via this make file here, which you could adjust if you need to, it will go ahead and install the actual mana software, the shell scripts themselves. This is the Ubuntu install that I mentioned, but I haven't actually fired up an Ubuntu box and checked it to see how well it works. And then the other software that it's going to install is in the download as well. So if we go to the directory that had the installation, the configuration scripts in it, etc. You'll see that all the configuration files are in here. And then, like I said, the host APD program within the toolkit is the main one that's going to be doing the heavy lifting for the access point. So if you wanted to change the access point configuration, you would do that in there. And that's where you're going to set up the BSSID. I noticed right away that the SOC analysts are probably going to pick up on this pretty quickly because the BSSID is 1, 2, 3, 4. That might stick out. You could change that in there if you're trying to do a test where you don't really want to get noticed. And then the SSID, you change that here by replacing the word internet with whatever. So that's pretty straightforward. And then the binaries are kept over here in user, share, mana toolkit. The main folder that you would be running from would be this run mana directory. And inside would be the scripts. We'll take a closer look at those here in just a minute. So one of the tools that comes with it is the full service equal access point. And that was the start nat full script that we just saw. Then there's also a simple equal access point. You might say, what's the difference? Well, the full access point is going to have a bunch of extra services running in the background that will do things like not just try to have the user's traffic route through your laptop, but also do things like defeat SSL, defeat HSTS, the HTTP strict transport security, and items like that. The simple access point is basically just an access point. It does have DHCP so that the person connecting can get an IP address, and it has some DNS capabilities, I believe, but it doesn't have all the SSL script and things like that. It's more of a good fit for when you control the mobile device that you're testing with, and maybe your developers came out with the latest and greatest version of your mobile app, and you just need an access point that you control, that you can see all the traffic going through. But you have physical control of the device, which means you can control the certificates that you put on it, and you don't really have to defeat the SSL per se. You can just install a rogue CA onto the device manually, and then create a certificate with Perf Suite and use that. So that's pretty useful. And I'll mention one other configuration that's in the Karma configuration file, the host APD configuration file, is the Karma Loud. This one is different than what you might expect. The tool will, by default, listen for the phones to beacon looking for their preferred access point that's in the PNL. However, when you switch the Karma Loud on, it'll start listening for just any traffic between a mobile device and an access point. And if it sees any traffic at all, it'll grab the SSID out of that traffic and try to become that access point, remember signal strength wins and it's high. So if your access point is much stronger than the real access point, with this feature turned on, you may actually convince the mobile device to switch over to your access point. Then the captive portal settings are configured in the same directory, and they basically have the same settings. So again, the PHY is the access point. There is no upstream because the captive portal doesn't require internet access. So you can essentially set up an access point anywhere, even a place that doesn't have internet at all, but it generates this access point that looks like there's internet access. By the time the mobile device logs in and doesn't get a connection to the internet, it's going to be too late. They've already typed in the username and the password. So running the tool is as simple as just running those scripts that we looked at. Basically what the simple access point is going to do is it's going to kill the network manager on Kali, because that normally would manage your Wi-Fi connections on Kali for you. And then it'll change the MAC address to a random MAC address. So on my device, it would change the MAC address to whatever. And then it'll go ahead and drop it into access point mode. So instead of this thing being a wireless card that I would use as a client, it becomes an access point as if you had a Linksys in the room or something like that. Has a DHCP server that runs on so that the users can get an IP address, and then it routes the packets through the laptop and to the internet connection that your laptop has. In my case, I've got a normal Wi-Fi card in my laptop that's connected to the internet, and hopefully, and then I've got this card connected to the laptop via a USB key. So that way I can have both connections. When you're done, you just hit enter and it stops the script. The full evil access point adds on the IP tables to route to the internet through the interface, and also it starts up SSL split, SSL strip, and the FireLAM services in the background. SSL strip is a service running that watches for those websites where you go to the website with HTTP, and the website redirects you up to the HTTPS site. So probably a lot of your own websites do this, where you're allowed to come in over unencrypted connection, but the server is going to force you to go up to the HTTPS version for security reasons. The way that most of the websites do that is they will send back to you a 302 redirect that says, the page you're looking for is not at http://acme.com, it's actually at https://acme.com, and then a browser will naturally redirect itself up to the secure connection. SSL strip can see these communications in the background. When it sees the 302 redirect, it will remove the S off of the HTTPS and redirect the user to HTTP. So the user just kind of loops around and is back up on the HTTP page. You might be thinking, well, how's that going to work? Because then the server is just going to send another 302 redirect, right? And they're going to end up getting caught in this infinite loop where they keep trying to get pushed up. Well, the trick is that the mobile device is actually talking to the laptop running SSL script, and then the laptop forms a legitimate HTTPS connection to the web server. So the web server is happy because it's connected via HTTPS, and it's not going to keep sending those redirects. But the encryption is only occurring between the laptop and the website. The mobile device to the laptop is unencrypted. Now the laptop can see all of the traffic flowing back and forth for that web connection. The FireLAM service is watching for sessions to be created. Effectively, a set cookie statement, more or less. When you log into a website, typically username and password gets validated. The server says, yes, that's the correct credentials, or perhaps, hopefully, checks the hash anyway. It'll send back to you a set cookie statement with your new session ID if everything's working properly. Some websites will issue you a session ID before you log in and then let you get to some pages afterwards if you validate. That's actually a flaw, but it can work either way. And FireLand will keep track of those session IDs. Then it will save those in a file, and when you run the FireLand tool after you've captured some of these logins, it'll present to you a web page with those sessions as hyperlinks in your Firefox browser. You can click on one of the sessions that the user had, and as long as the session token is still valid, it hasn't timed out, or they didn't hit the logout button to force the session to be destroyed, then you'll take over their session. You'll effectively be logged in as them. I have noticed that if you're switching between the captive portal simple mode and then going to full mode, or full mode to the no upstream mode or whatever, sometimes the tool will hang when it tries to run the tool again. And if you unplug your network card and just plug it back in, it seems to help. So sometimes you have to run a few commands that I've got documented in here, but generally that works. All right, so running the Evil Captive Portal is the same general principle. You just run start, no upstream, and it should work just the same as running the other two. So now we can go ahead and give a demo a go. So everybody cross your fingers and, I don't know, cross your toes and whatever it takes to try to get some help out there for this to actually work. But see what we can do here. All right. So I'm going to check to make sure that the card that I've got plugged in is actually being recognized. And it appears that it is, because when we do an IW config, we can see the WLAN 0 down here at the bottom. Since that seems to be working okay, I'm going to go ahead and start NAT full. That was the script that did not only the access point, but started up all the background services at the same time. Okay. So what we're looking for is down here at the bottom, but that went a little bit too well. You want to see it read the configuration file, change the MAC address, and then go into this mode where it's becoming the access point. It's listening for the client devices to search for their preferred access point, and then it's answering back and saying, yes, you're in range of your preferred access point. If the mobile device is in a mode that auto-connects, they should auto-connect. So we're going to leave this running over here. Now, I'd like to, let's see. So we get a couple of terminals going, so we didn't have to close that down. So if we did a TCP dump on that WLAN 0 interface, what we should be able to see is the traffic that's coming through the access point, through the laptop, and then back out to the internet. We should be able to record that to a file. Put that in my home directory. Okay, so TCP dump and then the interface, and then you want to use -W to write to a file, or otherwise it's just going to screenshot the screen really quickly. So we'll go ahead and set that service just running in the background. And you notice there's some packets that's already traveling through the access point. Okay. Okay, I've got a Nexus test tablet here. I'm going to use our super secret pattern there to unlock it. That was tough. All right, and I've set up that that default internet access point that we mentioned earlier in the config file. I've got that set up for testing purposes, so you probably don't want to join that. And I've purposely joined this Nexus to it so we can do the demo. So I'm going to go to Chrome and I'm going to open a new tab. And let's try to go to Yahoo common site. Make sure you all can see this okay. Okay, so let me move this camera just a hair. Apologize for all the jitter, but I want you all to be able to see the URL bar, hopefully. Okay, it's a little too faded. I'm going to zoom in. Okay, so we did make it to Yahoo. And does anybody see anything funny about the URL that we ended up at? We are on legitimate Yahoo, by the way.
For devs.
Right. So what's happened is that Mana has recognized that the sites can protect themselves with the HSTS, the strict transport security. And one of the tricks that it can use is that it has a DNS server running. So it can legitimately create a local DNS record for quaddub.yahoo.com and put the real IP address to Yahoo for that record, and then redirect you, using those redirections to the quaddub instead of the triple dub. Does that make sense? So the reason that that works is not because there's anything that Yahoo's done wrong, or because this works on just about any site. It just happened to pick them because they have really good response times, and they're already preloaded into the toolkit. But the reason it works is because the HSTS is on that domain that you're trying to go to. It's actually an HTTP response header. If you look at your header traffic with, say, live HTTP headers, you'll see that coming back from the site. But it doesn't apply to other domains, of course. Why would, like Google issue an HSTS for Yahoo, for example? That doesn't make any sense. Well, this domain, while being very similar to quaddub, it's still a different domain. So it's not, the HSTS is not working to do the protection. Now, you might wonder, what about SSL? So we'll go over here and we'll go to sign in. Okay, and now if you can see that URL, okay, this is the real site, but what's wrong with that URL? What's that? It's not HTTPS. Now you're seeing the SSL strip come into play, where between the Android device and the Mac, we have an HTTP connection. Between the Mac and the real server, we have an HTTPS connection. So, is there something wrong with this website's SSL? Did Yahoo do something wrong? Well, no, that's how SSL works when it's one way. So the SSL that we're all used to on a daily basis, we're verifying that the server is the legitimate server, that we haven't been tricked into going to the fake yahoo.com. And they have a certified certificate that's been vetted by a certificate authority that we all trust because the browser tells us that we all trust it. And it's legitimate. However, we don't have a certificate coming from the Android device going to Yahoo to tell Yahoo that we're the legitimate Android device. That doesn't exist. Well, at least not in my Android. It is possible to have that protection. Later on, when we look at remediation, we can talk about mutual authentication via SSL certificates. But that is really only practical when you control both ends of the connection. All right, well, let's try to give it a go. Let's see if we can log in. I'm going to use a fake username and password. One, because it'll make it easier to find in our logs later, but two, I don't want to draw a login in my Yahoo account. So I'm going to do Canary Yahoo. It's a pretty easy string to find, I suppose. And Canary Pass.
Really, Jeremy, the fact that you still have a Yahoo account tells us all.
There you go. Don't hire this guy, right? Be Yahoo's. I also have a Hotmail account. Okay, and of course it's invalid username and password. We already said as much. So, but let's go back over to the window that we had the TCP dump running in. Okay, so it's still grinding away in the background. And just do Wireshark on that Android, I think it's called Android intercept.pcap, yeah. Okay, hopefully this doesn't turn into too much of an eye chart. So, a lot of stuff there. Let's narrow it down a little bit. Okay, if you click on the magnifying glass in Wireshark, or you can do a Control F if you like, then it'll pull up the find packet feature, and then you can click on the string because we're just looking for a word. And it was Canary Yahoo. Thank you. And then we're going to look at the bytes because it should be in the text of the packet. Okay. All right. So let's bring this up a little bit so people can have a better chance of seeing it. So here's the line right here. It's 35519. You see the post out to M. That's the name of the page. It's M. That's what they called it. And then you'll see down in the bytes is the Canary Yahoo and the Canary Pass. And again, there's nothing wrong with Yahoo's site. This is how SSL works. This is how Wi-Fi works. It's a feature of the access point that you are allowed to roam from access point to access point. It's very convenient. All right, so we can terminate this Wireshark here. Okay, and I'm going to hit enter to terminate the script. Like I said, if you tried to start it again right now, or you tried to switch away one of the other tools and run them, sometimes it kind of tends to hang. The card seems to be busy. It seems to help to just unplug it and wait until you see kind of the messages go back, and then plug it back in for the next round. We got away with one demo. That might be too much to ask already, but let's try another one. Okay, so we're looking for the host name and then the MAC change, and then it's going to read the configuration file. And then after it reads the config file, we're looking to see it start to impersonate access points and create the access point with the name in the config file and so forth. And if not, sometimes you can just release the WLAN 0. That works. Sometimes you can reboot and try again. Whatever works. So. try to disconnect it one more time. Config. Is there any questions so far while we're waiting for the see if the tool's going to run? Oh, well, let's see if it worked. Okay. It kind of looks like maybe it did something. Let's check it out. We'll give it a try. Okay, it says there's a Wi-Fi network available. We're going to try to connect back to our test network. All right, try one more thing. If this doesn't work, we'll give up. Let's try to reinstall it. See the FBI surveillance being hit. That's good. Okay, so hopefully here it'll read the configuration file and then it'll start to do the impersonation. All right, well, we'll see if we can come back to that at the end. If it comes back, we'll take a look at it. So, assuming the demo worked, well, the first one worked, so we were able to capture the traffic. We got around the HSTS, the SSL, using a combination of the DNS spoof and then also combine that with the SSL strip. So, what can you do? Well, if you're a developer, I think the main thing you do is implement the certificate validation, but also the pinning. So what do I mean by validation? Well, if you're doing mobile development, you don't have the browser to rely on. So you can't count on all the validation that comes with Firefox and Chrome and all those. But what you can do is you can go ahead and do the validations yourself. So you can say, well, is the name that the certificate is assigned to, is the CN, is that correct? Is the certificate expired? Is the certificate have a valid signature? Those sorts of things. You can also only allow the certificate to be vetted by certain certificate authorities. And you can pin the certificate. So you can say, well, I'm only going to honor certificates that are signed exactly by this CA or this group of CAs in this way. And so the downside of that is that you effectively hard-coded that into the mobile app, and if you need to change the certificate down the road, you have to simultaneously update the mobile application and the certificate at the same time, or you have to basically pin two certificates, the old one and the new one, and run them both simultaneously. It gets into revocation issues. But that is a very strong defense. It's hard to get around that. Of course, you can disable HTTP access entirely if that's possible. It depends on who the customers of your site are, whether or not you can do that. But if you're in an internal network and you're running applications inside of your own fence, then you can just simply turn the HTTP off entirely. That prevents applications from being able to do the trick where if someone comes in on HTTP, they bump them up to HTTPS. So SSL strip wouldn't really have a foothold in that case. Definitely want to use the strict transport security, but the trick there is that you have to do it on all the pages and all the subdomains as well. So if you put it on Acme Corp, then you need to also have it on www.acmecorp and then login.acme.corp and so on, and ensure that that goes on every page. And then use the mutual authentication if it's permissible. So you would pretty much have to control both ends of the connection in that case to use mutual authentication. You might say, well, we control the mobile application, we wrote it. So sure, you could do mutual authentication in that case, but you may run into a problem with distributing the client certificates to the end users. If you have devices that you're giving out to the users, that becomes a lot more practical. But if you're doing a BYOD or something like that, that's going to take some figuring to get that to work. So as far as users, which is all of us, basically, if you're doing a sensitive transaction, you want to try to do that on a trusted computer, trusted network. I like to use Ethernet, personally, at home. If I'm going to be doing banking or whatever, I like to actually have an Ethernet connection. I've installed one in my office. Wasn't too hard to put one in. You can just plug it in real easy. You want to be aware of URLs that don't look right. You all actually caught that one pretty fast, the quality. But how many times do people go to websites, and as long as the website shows the right content, there's no way to look at that URL, right? So that's more kind of a user education or awareness campaign there. If you can stand it, don't automatically connect the Wi-Fi's. In Android, that may mean forgetting the network. You can long press on it, you click forget. If you're in an iOS, there's a checkbox you can uncheck that would say automatically connect. So I think iOS might be a little more flexible in that way. At least on my Android, which is the Nexus tablet, there's not an option per network to say whether you want to auto-connect or not. But you can forget them if you want to, after you use them. And then, of course, you want to use SSL and go directly to the site via SSL. So you want to go to HTTPS, Google.com or what have you. Try to avoid the temptation to leave the S off. And you may even want to try to see if there's some plugins for your browser that would automatically append the HTTPS on your behalf for you. That's available as a plugin or an add-on in Firefox, and I believe Chrome has that as well. I think that even a version for IE has come out since that original concept where it'll watch for you in the background. And of course, if you're a corporate administrator setting up a Wi-Fi at the office, you definitely want to use the E with the mutually authenticated certificate base, because in those cases, you probably control both the device that's connecting and the Wi-Fi access point itself, since these are corporate users that have corporate equipment. And have them authenticate each time. So I am going to leave about 5 minutes here for questions, or if nobody has any questions they want to ask out loud, you can always come up. And here's my contact information as well. I'll bring the slide back up. I'm going to check on our demo to see if maybe it started working. Check it real quick. Okay. Oh, I don't see it, so that's a bummer. Let's try to see if I can at least show it to you. Oh, very good. So I can't get to it from my Android because I'm not able to get this card to be the evil access point again. However, I'm just browsing to it from Linux itself. I'm just browsing local hubs, so I'm actually going to the access point. And this is the login that you would see. So it gives you the choices of which service you want to use to log in: Google, Facebook, Twitter, Microsoft, or a local account. It has the option of registering for an account if you like. And then, of course, the user would put in their username and password, presumably correctly or at least close enough for that service. And then once they did that, it would be in the log. So if we did like Canary captive portal, and then try to log in, oh, that's handy. Of course I want to remember. So nothing's going to happen. This is not a real captive portal. It's just one being spoofed. But then if we went over to the access log, let's see. So let's see, right here, I'll move this up just a second. So right here in the last action in the Apache log is the get to the index.html, and it does a get on purpose. Gets are logged, posts are not usually logged, so that's why it purposely does a get to post a form. And you can see that the password that I use is right there in the log itself. So by the time the user figured out, this internet connection stinks, it's not going to work, it's not working for me, maybe let me try my Yahoo ID, or, by that time it's too late. It's definitely effective on pen tests. So, all right, does anybody have any questions? Still got a couple minutes left. All right, well, come on up and see me if you want to chat, and leave my contact information up for 2 minutes. Thanks.
No, that was
Mostly we're switching back to we have a 6 like after the scene. There's a lot of very different.
yeah.
No. It's almost like a salary. All the speed, you know what I'm saying? I don't know.